Can you give us an example of safety critical softwares?
So safety critical software is everywhere. It's all around us. If we define safety as any instance where software can cause us harm, when you think of it that way, the software is all around us. So in a car, for example, the software which your brakes are now run off software and your steering, these things used to be physical mechanical components, and they're now all done by software. And a lot of modern cars don't actually have any physical connection with the brake pedal and your brakes. It's all, done by sensors, and software is running that in planes, autopilot, and all of the extra tools that they have. The pilots have to help them pilot the plane. It's all run by software. Medical industry, the machines keeping people alive, all have software in them. So it's everywhere. And if you think any place with software where there's potential to cause harm to a person, that's what we define as safety critical.
What is the future of safety critical systems in automotive?
So automotive has a big push for safety critical systems for, I think driverless cars is one of the big focuses for most automotive companies. Everyone wants to be the first to have a safe driverless car. And I think that's really where a lot of the focus is going. How do we design safe driverless cars? How do we use things as complicated as machine learning models, which are so complicated that no one really understands, or no one person certainly understands how they work. And how can we use things that aren't fully deterministic safely? And I think there's also a drive to use more open source in automotive applications. So we're seeing a big drive for a lot of automotive companies trying to use Linux as an operating system, trying to build safety applications on top of Linux. So I think the future of safety critical systems is really answering these big questions. How can we use huge, complicated software projects like Linux in safety critical applications?
What is Safety Theoretic Process Analysis, SDPA?
SDPA, it's a safety analysis technique which was developed at MIT. It's a way to analyze a system and derive safety requirements. It's a really great technique to use. It's top down as opposed to bottom up, which other techniques are like FMEA. And this means we can abstract complexity. So where we have huge bits of code like Linux system, which is around 17 million lines of code, I think is the best guess. It allows us to abstract that complexity out, and we can derive requirements. And then once we've derived requirements for individual sort of big units, we can zoom into those and drill down into what bits are important. We can also analyze how different components in the system interact with each other. So we can analyze software-human interaction, software, hardware, and everything, how these things interact. And it's a different way of thinking about things rather than focusing on just failures, which other analysis techniques do. We look at, well, what happens in situations where everything's working as it's designed, but the way we've put them together just doesn't quite work. I think it's a really great technique to use for software.
Can you give us some examples of your work in Codethings around SDPA?
Yeah, so we've had a couple of really interesting projects at Codethings. One of them, the first project with SDPA we did, was working with MIT called AV SDPA. So that was an analysis of an autonomous vehicle. It was on the open source autonomous vehicle platform Apollo. We used version 2. This was really our first venture into SDPA. It was really interesting seeing how the autonomous vehicle software interacts with the vehicle, interacts with a safety driver in the vehicle and other components that are there. And it was fascinating to see problems which we didn't think would come up that arose from using SDPA. I think the other interesting project we're running at the moment with Elisa is looking at OpenAPS, which is an open source artificial pancreas system to help diabetic patients, helps them to manage administration of insulin. So this thing runs on some hardware like a Raspberry Pi. It's all open source, and it interacts with an insulin pump and glucose monitors, and helps to regulate the insulin dosages. And that's really interesting too.
Thank you very much for your time, Shaun.